right? All these points include the existing ground surface. And I don't, existing surface. And I don't put in negative or positives, because I'm working with this point, and anything to the left, I'm measuring from the left, and anything to the right, I'm measuring to the right. But if I want to correctly calculate that area in there, I have to represent it in terms of math. So what thing should get negative?
X values to the left of it.
Okay, so tell me which letters.
H,
Okay, point H has to have a negative on the X.
C,
C has to have a negative,
and
L.
L.
and L,
Uh-oh, it went away.
That's,
and D has a 0, right? D is on the center line.
that's it.
Is there another number that should have a negative?
Yeah.
The 15.
Not
right?
R,
G.
because R is to the right.
G.
The
G is to the right also, right?
the negative, the 15 under the second
Oh,
H.
to the right of that. Okay, I get it.
So here is our origin. Don't you agree that anything to the right is going to be a positive X?
Yeah, I was just going around in a circle. I mean,
Okay.
going around the thing.
Okay. Anything to the left is going to have a negative X.
Got it.
But everything above is going to have a positive Y.
Yeah.
So in this case, since it's a cut, all the existing ground surface has a positive Y, and I make sure that all of these are positive.
Can you explain
So, yeah.
why you made the statement that it should be all
Not always,
what
only
was that?
when you're cutting.
In this particular one, it's positive because we're doing a cut. When we do a fill is the road is going to be above the existing ground surface, and we always measure from the base of the road, so we're going to have negative Ys.
I see, okay.
But
Okay.
not until we want to calculate the area, right?
Right.
Okay.
So it'll be negative values for a fill.
Negative Ys.
Not.
Negative Y values for the fill.
Like you just look at it like an actual like graph,
Right.
like the how
So
graphs are set up.
if I brought
That's the X.
this back, oh, I can't write on there.
Huh?
Negative X values for a
Okay, I understand.
I'm not gonna write that down because it's like going too far into it. Like, I understand it already.
Does everybody get that? So if you were going out in the field, if my road goes from here to here, when you're doing cross sections, you're gonna get, so my surveyor is on the equipment, hang on a second, Allison, is down there, and I have the pole, and I know this is about where the center line of the road is. I'm gonna put my pole here and let the surveyor shoot it, and then I'm gonna go off the road, off, where there are highs and lows, and I'm gonna do the same thing here, highs and lows. And then we mark it in the field book, we would set it up like this, where the Ys are above, the X's are below. I'm gonna start with my middle point that's on the center line of the road, and then I'm gonna represent all the points to the left and all the points to the right.
Which way was that?
So wait,
road?
so if the road is coming from here to there, all these would be on the left, all these would be on the right. And as I move to the next cross section, we're gonna put all these points to the left and all these points to the right. Allison?
Two things, so all the Ys are positive then, correct, all the Ys are positive?
Oh, I see, this is what you were talking about, Seth, when I said always positive?
Yes.
So these I'm on the whiteboard, right? All these values are always represented as positive, always. You orient them, you set them up, if they're to the left, they're on the left, if they're to the right, they're on the right.
No, what I'm asking is the,
On this part,
yeah, that part where you have all the pluses, all the Ys on.
all the Ys are positive because this is the origin,
Correct.
that's the coordinate of 0, 0. So any of these points, L, C, D, E, and R are all above the origin, so they all have positive
So does
Ys.
that mean all the horizontal on that side, means they're all positive?
That's right, so these are all positive,
Okay. Just making.
yeah.
I have one more question.
Yeah.
Is this calculating the volume of a cross-section of the road or of a profile of the entire road?
Okay, so you're correct in that when we represent soil, quantity, we have to call it volume. But right now, we're looking at a slice, we're only looking at a 2 dimensions. And this is only the cross-sectional area. So when we do the double area method, did anybody do the numbers yet and find out
No,
what
we weren't
the
supposed
math
to.
is? Let's see, I might have it in my book.
No.
JJ, do you have it from last year? What
You
that
can do it.
area is?
Off the top of your head, man.
Come on, you should know this one.
Just do it in your head real quick.
You were just telling me the answer earlier. But I forget.
No. I didn't write that.
She's treating it like a normal.
To calculate it,
The O is, the crosshairs.
So what you would do now is you would go cross, cross,
Yes.
cross, cross,
That was
cross,
the
cross,
question I
cross,
asked.
minus,
Why did you say
and then
all
negative, and then divide by 2.
I don't quite get why that would be a negative. Wouldn't it all be positive if it fails?
Yes, but,
Oh, it's because that's the only way it works in the formula.
no.
Right?
So take a look at this picture, this cross section up here. Geometrically, if I am measuring everything from the origin, the only way to have my L and my H and my C on the left side is they would have to have negative X's. If I kept the positive H, L, and C X's, the picture would actually be like, not like this,
So
the
it
picture
only-
would be like this, and you would not be calculating the
So it's only
actual
done to make the formula
geometry.
work.
Say it
Only-
again?
It's only done to make the formula work.
It's only done to make the formula work correctly.
How did they figure it out?
They represent the numbers positive.
Wait,
so
everybody's-
the second one-
Well, remember the planimeter? Brian, you brought the planimeter, and I don't know if anybody got to play with it or not, but the only way on AutoCAD or any way to calculate the area in this method using coordinates is you have to make sure that they have positive or negatives because you need to know the geometry of it. And if the ones on the left did not have a negative X, the geometry would not be like this, it would be like that. Porter, you were saying something?
Oh, no.
Okay. Z, question?
Oh,
Your
I
hand
was
is on
thinking
your head.
that this comes from the cross product, right? Using the vectors, that's what you do.
This is just an area of a.
Right, no, but I'm saying, I was thinking about this formula for a
No,
moment.
no, it could be,
The vector,
because cross products is when you do R cross F,
right,
and you are doing multiplication,
right.
but I never thought of it that way. You know, it's interesting because, for me, to understand math, they need to give me a picture in a real world for me to understand math. Z, you're like the opposite.
Yeah.
You got the physical picture, but you have to understand, you need to know the math. It's very interesting.
I wonder.
I'm just saying,
Think
because
differently.
it seems like it's a Jacobian cross product, that's how they get all the
Probably
vector.
is,
You're
right?
using,
No, I'm
right?
not quite- It's like,
So I'm saying, if you have a curve, you would literally, it wouldn't be just a cross.
Yeah.
You have to-
Well, what if you moved your thing over, so everything was
It doesn't matter,
positive?
it will still
Like your
work.
X and Y, would it work?
Yes, yes.
Like if you moved that one, all the way
Yes,
over.
then you
Doesn't matter where you put it,
It
doesn't matter where you put your origin, because it's gonna change everything.
Exactly.
Okay, so
Yeah.
Melissa
So
has
it
a
would be
really
like
good
fine.
point. If we made the origin at point L,
Yes.
if we made the origin at L, well, no,
Not the origin though. It would be 0.
if we made the origin right here,
Yeah, exactly.
everything would have a positive value, X's and Y's.
Yeah.
However, we're not mathematicians, we're surveyors, and surveyors have a standard way of representing coordinates
Yeah.
on a cross-section, and you have to use the origin on the bottom, and then you arrange it with everything to the left, and everything to the right,
But you should technically get the same answer
You will
if you
get-
set them up.
You will get the same
Yeah.
answer.
If you set them up in the sequence that they're supposed to.
That's
be.
correct.
But
Brian?
The cross product isn't.
I was originally gonna think you can do 2 calculations if you wanted to keep all the numbers positive.
I'm just saying in general.
Just calculate everything to the left,
Okay,
calculate
did
everything
everybody
to the right.
hear what Brian said?
I mean, I assume you're probably only have maybe a couple more multiplications to do. That's
Yeah.
another way to do it. Is that?
Yeah. So Can we do it? Yes, mathematically it'll come out, but it won't be according to the standard way of doing it.
Okay.
But so what
I
Brian
understand what you're
asked,
saying, yeah.
Brian said, can't we just look at the left side of the cross-section and calculate it and use all positives? And then on the right side, calculate the area using the double area method, using all positives? Yes, because then you would have two areas calculated and you'd have to add them together at the end.
But then there's
However, that's
one
not
more
the
step.
accepted way of doing it.
Standard.
And there's also another step that you could potentially
And it's another step.
have a mistake or something.
Patrick?
If you wanted to find the volume, could you do the same process again, rotate it 90 degrees?
Yes, but it's gonna be a lot easier. We're
Oh.
gonna do it an easier way. We don't need to do that complication.
Okay.
Okay, so we'll look at it, because you're right, in the end, both you guys, you and Ivan both said, we're talking about volume, we're not really talking about area, but first I wanna make sure that you're comfortable calculating the area. So did anybody get an answer yet?
Yeah.
Oh, good, Matt.
I got 710.235.
Say it again?
710.235.
710, and this is square feet? You
Yeah.
didn't convert to acres, did you?
No.
No, okay. And would
It is.
would acres be appropriate?
No, because
Would I ever ask you to convert this to acres? The answer is no. Why?
too small.
It's too small, it'd be like.
No, that's not the answer.
Because you don't use
It's a
acres
yes.
to measure.
It's vertical. It's vertical.
It's vertical.
Oh.
Acres is only used for horizontal spaces,
Still
right?
in horizontal.
But it's really good, and it is, it's gonna be small. But it's just that it's,
That doesn't
acres are horizontal pieces of land, not vertical. But that's different.
That's a different, there's a whole different.
That is acre feet. It's still the acre.
The
The acre still represents horizontal. Do you guys know that when you represent water, a body of water, you call it acre feet? I mean, that's gotta be the weirdest English system thing out there,
I know.
right? It's gotta be. But it's acre, it's how many acres of water covers, again, horizontal area, times its multiplication of how deep it is. Acre feet, how many acres by how many feet? Anyway, junior year, you'll see that. You'll remember us all. Daniel, Nathan, take a big smile. Big smile. So everybody's gonna think of this face, Nathan, when you guys learn acre feet, because he just introduced it to us. Thanks.
Thanks, Ethan.
I saw you at New Brighton.
Did you?
I was in the car.
He was just behind you.
He didn't want to get out of the car.
He was following
No,
us.
he just didn't want to pretend like he knew you in front of his friends. I'm just kidding.
I'm not getting out now.
Okay. Did anybody else get 710 feet squared? Oh, great, that's it. Good. Okay, I think we should take a break.
That was good.
Okay, 15 minutes.